Climate State, researching and reporting climate change and extreme weather.
Operation Icebridge. Icebridge is off to a strong start this year, having completed 7 science missions over outlet glaciers, sea ice, and ice sheets, and covering a broad range of territory both east and west of the Antarctic Peninsula. This is exactly the kind of start mission managers were hoping for when they prepared the aircraft thousands of miles away in California 2 weeks ago.
Dryden has been invited by headquarters to play a pretty major role in Operation Icebridge when it comes to studying the Antarctic continent. So we prepared the DC-8 with numerous instruments to fly long-duration flights out of Punta Arenas, Chile. For this year's campaign, we've got a complement of about 17 scientists will be flying on board, and we've got 7 instruments installed, and they range from LIDARs to radars to a gravity meter as well, which is kind of a unique instrument. And at the end of the campaign, when we've flown roughly 15 sorties, if we've hit the targets and they've successfully collected data, then we know that we've done a good job.
So this is the 4th year we are going back to Antarctica with the DC-8, and we have analyzed the data from the previous flights and the previous missions, and we see that the ice sheets, for example, like Pine Island Glacier, are rapidly thinning, and the thinning is accelerating and it's spreading further and further inland. So this is something we really have to keep an eye on and go back every year in order to make sure we collect the data that we need to feed into computer models that allow us to make predictions for the future.
Until today, the mission had yet to feature a return to the site of last year's discovery of a massive rift in the Pine Island Glacier, a huge flow of ice that has been called the weak underbelly of the West Antarctic ice sheet. Satellite images show the glacier is not calved yet, but when it does, could produce an iceberg the size of New York City. Keep in mind that the main science objective of Operation Icebridge is to study how the ice is changing in polar regions on a much broader scale, not searching out calving events. But being at the right place at the right time provided a scientific bonus.
Icebridge did a great job of surveying that crack and giving us a great visual on rift dynamics. I mean, the ice melange that's in that rift is very interesting. Icebridge is based out of Chile to fly all sorts of flight lines associated with bridging the gap between IceSat and IceSat-2. They happened to survey it last year, just fortuitously. It would be awesome if they could go back, for sure. It wouldn't be directly their science, but it'd be great to see the evolution of that rift, or possibly even a new survey associated with the new calving front.
Today's mission featured a rare high-altitude flight over the Pine Island Glacier. As the aircraft returns, we wait for news of what the team found when they got there. We start with a visualization of AMSRE data from the Aqua satellite, showing sea ice, or frozen seawater, pulsing over the course of months around the Antarctic continent. Icebridge often passes the scenic Antarctic Peninsula on its way to survey the continent's ice sheets, glaciers, and surrounding sea ice. The peninsula's mountains are habitually shrouded by clouds, but today we have a clear view. As we descend, we see vast fields of sea ice. Large pieces of sea ice are called floes, and these formations often collide, creating thick ridges along their edges or raft over top of each other. This ice appears to be thick enough to be second-year ice, or ice which survived a summer melt season. Darker, grayer ice appears to be more recent, and might be around 10 centimeters thick, while the white ice covered by snow is probably more than 30 centimeters thick. The area in the lower center here is so smooth, it might be just a few hours old. This is frazzle ice. It's granular like a slushy beverage and is created by very dynamic conditions of turbulence in the water. This is a region of brash, containing sea ice and a few icebergs. IceBridge measures Antarctic ice from 500 meters above the surface using radar, laser altimetry, and these crisp images from the DMS, or Digital Mapping System. Here, we have ice that's holding fast to the shore, and immobilizing iceberg is created from a nearby glacier or ice shelf. These slabs of ice from continental ice shelves, sticking above the water by perhaps 50 meters, are large and flat enough to be called tabular bergs. Finally, the slowly setting sun lights up cracks or leads in the sea ice as we head for home. Operation IceBridge has now returned to the Pine Island Glacier not once but twice in 2012. And the year-old giant crack in the glacier, poised to create an iceberg the size of New York City, well, it's still there, and that iceberg has yet to break free. But the rift has grown longer, much wider, and spawned a secondary crack. Before we talk about when that mighty berg will be born, let's take a look at the IceBridge missions themselves. IceBridge's first return to the glacier was a high-altitude flight over the entire region, including the Thwaites, Smith, and Kohler glaciers. After this campaign is over, scientists will be able to compare this broad survey with previous year's measurements in order to better document the rapid and widespread changes in the region over time. For the second mission, NASA's DC-8 flew, as it does for most IceBridge flights, at 500 meters above the ice. And this mission was about creating a brand new set of data. The flight lines took the team over previously unmeasured tributaries of the glacier, and also surveyed the bedrock below them to provide a baseline for measuring change in the future. So while this focus on the Pine Island region, NASA Goddard calving specialist Kelly Brunt says the ice in the region is substantially thinning, and its flow is accelerating.
Ultimately, the change that we see in that whole region, not just Pine Island, but also its neighbor Thwaites Glacier, this change represents the largest input to sea level rise from an Antarctic source.
The rift has been an intriguing phenomenon to watch over this last year, but is it a really important event?
When we talk about Antarctica and we talk about the health and state of our ice sheets, we talk about mass balance. And what you have on one side of the mass balance equation is accumulation or snowfall coming in. And when we talk about balance, that has to be balanced by things coming out. And in Antarctica, that happens either through surface melt or basal melt, or the big number in Antarctica, which is calving. Calving accounts for 80% of that side of the equation. So when you see calving in Antarctica, even calving where we use small states or the island of Manhattan as a unit of measure, this is generally very normal. It's part of the process.
However, Brunt says once the glacier calves, the new calving front will be further upstream from any calving front we've seen in the last 40 years.
I've used the analogy of a fingernail to talk about calving. Generally, if your nail breaks in the white, it's normal and you don't worry about it. If your nail breaks below the white, you think about it, you remember it. If you lose your whole nail, that's a big deal. Much of the calving, the 80% of the net loss through calving, can be equated to losing the white part of your fingernail. Things that we saw in the early 2000s in the Antarctic Peninsula side, the Larsen A, the Larsen B, that's equivalent to losing your whole nail. What's going on in Pine Island is probably that intermediate, that we've broken our nail and it's below the white, and it's something to watch and something to monitor over time.
As a byproduct of the recent IceBridge flights, the team got some great views and measurements of the evolving crack, which has been filled in somewhat by blowing snow. The crack appears to have only a short distance to go before a new iceberg is born. It's still hard to know when that will happen, but conditions seem to be right.
Sea ice acts as a buttress or a dampener for sea swell that actually protects the front of these ice shelves or the front of these floating glaciers from calving. So the fact that there's no sea ice in front of Pine Island Glacier right now implies that it might be in a state that's sort of primed to calve.
After IceBridge heads back home from this campaign, its data will be used to monitor the state of Antarctic ice sheets, while satellites will continue to watch the rift in the Pine Island Glacier as the melt season continues. Okay, John, could you give us a sense of how this mission was designed, your weather thoughts coming into it, and the scenery coming in over the calving front, that sort of thing?
Okay, sounds good. My name is John Sontag. I'm a senior scientist with the ATM team. That's Airborne Topographic Mapper. Today's mission was called the Recovery Offshore 1 mission, made up of 6 parallel lines spaced at 20 kilometers. It's called that because we concentrate in the area where the Recovery Glacier, which is a major glacier in this part of East Antarctica, drains into the Filchner ice shelf. It tends to be difficult to get measurements to help us understand the shape of the cavity of water, ocean water, beneath an ice shelf such as the Filchner, especially a big one like the Filchner. And with our gravity instruments and our radar instruments on board the DC-8, we are able to collect measurements which allow analysts and scientists to deduce the shape of those underwater cavities. And that's important because by knowing the shape of those cavities, scientists can begin to get at the interaction of these glaciers with warm ocean waters, which it has been determined within the last decade or two by the glaciological community that the interaction of these large glaciers and warming ocean waters tends to be quite important in determining their future behavior. The weather today was probably not what you would call ideal. We knew that there would be a cloud layer between 8,000 and 10,000 feet, and we had a lot of confidence in this particular forecast. So our transit in this morning took us over the southern part of the Antarctic Peninsula and over the extreme southern part of the Weddell, just in front of the Ronne ice shelf. And sure enough, most of it was clouded, as the models predicted it would be. We could see bits of sea ice surface here and there. But when we made our descent into the Filchner ice shelf area, we could see the edge of the ice shelf and the edge of Berkner Island. It was clear skies there. And when we got on site, we were very pleased to see that the forecast indeed held up with the low sun angle that you get down in these parts, and just a beautiful, beautiful, beautiful scene. So it went very well today.
It's a long 12-hour day, flying out of Chile to one of the farthest points Operation Icebridge can reach in the Antarctic, the Getz Ice Shelf. We know from satellite measurements that this 300-mile-long floating ice shelf is losing mass, but with Icebridge data, we hope to find out something about why and how fast this ice is disappearing. After crossing the windy Drake Passage at high altitude, we descend and are treated to a tour of Antarctic ice in almost all its forms. We see different kinds of sea ice, from thin gray sheets to solid fields covered in snow and littered with icebergs. We see gigantic tabular icebergs, taller than a house and longer than a runway, that were once part of the largest piece of ice on Earth. And we see the ice sheets themselves, smooth in some areas, heavily crevassed in others. As we arrive at the survey area, we come across the calving front of the Getz Ice Shelf. This 10-story tall face is currently where mighty icebergs break off into the ocean. But it may not be the front of the ice shelf for long. Upstream, a crack is forming, threatening to calve off a new tabular iceberg and move the calving front inland. Even from just a few thousand feet above, the scale is deceiving. The crack looks like something you could jump across, but our laser data tells us it's 45 meters deep. And with our digital photography, we can estimate the width at more than 13 meters. But back to why we're here. We need to get a better handle on the bathymetry below the ice shelf. Basically, the shape of the ocean floor below this floating ice tongue. The shape will help us calculate the circulation of the warm water, well, comparatively warm water, that's eating away at the ice shelf from below. Our gravity meter, or gravimeter, actually senses the mass of rock below the ocean, giving us a picture of the grounding line, where the ice sheet leaves the support of land and begins to float on water. But that's all on the marine side. We also need to understand what's happening inland. Our laser data tells us how much the surface of the ice shelf is lowering, and our ice-penetrating radar tells us the shape and elevation of the bedrock below the ice, which helps us estimate how much ice will flow into the water and how fast. On the inland side, we pass by a ridge in Marie Birdland. Most of the distinctive mountains peeking through the thick ice here are extinct volcanoes from the Cenozoic era. They're a welcome scenic change from the wide, flat landscape that covers so much of polar regions. After collecting nearly 5 hours of data, we head for home and get a rare, clear view of the Antarctic Peninsula with its stunning mountain chain and almost alpine glaciers. Out the port side of our DC-8, we watch the sun set at its incredibly slow polar pace, cross the Strait of Magellan, and prepare to land back in Chile well after dark. Of last year's discovery of a massive rift in the Pine Island Glacier, a huge flow of ice that has been called the weak underbelly of the West Antarctic ice sheet. Satellite images show the glacier is not calved yet, but when it does, could produce an iceberg the size of New York City. Keep in mind that the main science objective of Operation Icebridge is to study how the ice is changing in polar regions on a much broader scale, not searching out calving events. But being at the right place at the right time provided a scientific bonus.
Climate State, researching and reporting climate change and extreme weather.
Operation Icebridge. Icebridge is off to a strong start this year, having completed 7 science missions over outlet glaciers, sea ice, and ice sheets, and covering a broad range of territory both east.
Previous flights and the previous missions, and we see that the ice sheets, for example, like Pine Island Glacier, are rapidly thinning, and the thinning is accelerating and it's spreading further and further inland. So this is something we really have to keep an eye on and go back every year in order to make sure we collect the data that we need to feed into computer models that allow us to make predictions for the future.
Until today, the mission had yet to feature a return to the site and west of the Antarctic Peninsula. This is exactly the kind of start mission managers were hoping for when they prepared the aircraft thousands of miles away in California 2 weeks ago.
Dryden has been invited by headquarters to play a pretty major role in Operation Icebridge when it comes to studying the Antarctic continent. So we prepared the DC-8 with numerous instruments to fly long-duration flights out of Punta Arenas, Chile. For this year's campaign, we've got a complement of about 17 scientists who will be flying on board, and we've got 7 instruments installed, and they range from LIDARs to radars to a gravity meter as well, which is kind of a unique instrument. And at the end of the campaign, when we've flown roughly 15 sorties, if we've hit the targets and they've successfully collected data, then we know that we've done a good job.
So this is the 4th year we are going back to Antarctica with the DC-8, and we have analyzed the data from the